Hello all, welcome to Tech with SAS. In this video, we will talk about Bloom filters. So we will cover what is Bloom filters, how they work, and what are the various use cases, right, in the real world. So we'll talk about almost everything about the Bloom filters. So to start with, let's take an example to understand the exact use case, right? So for example, you want to create an email account. So for that, first you have to choose the your user ID or first name, whatever, right? So basically you choose your user ID or email, right? So that should be unique because whoever is going to use the email, they must be having a unique email ID, right? So now just think about, right, Gmail will be having billions of record in the backend, right? Because it's a very popular email system, right? So and once you type on the user prompt, right, on the create account page, it maybe in few milliseconds it says whether this email ID exists or not exists, right? So how it does so efficiently, right? Because if we do a simple search query, right, so it will take hours to search because in the backend database there might be billions of record housing, and searching through all the records is really difficult, right? So now, but they're able to do it very fast, right? So how they are doing it, so we have to understand, right? So now you got a context that whenever we have a huge number of strings or in the back end, right? So or users, whatever the case may be, right? So and you want to search that particular database or repository very fast, so then in that case the Bloom filters are used. But before that, right, so there are other ways. For example, you have a very simple email app, right, where you are storing everything in database, and without Bloom filters, what you do, right? You basically store all the email IDs in the database, and then to check whether the new email ID which you want to create exists or not, you will do a simple search query. But right, search query is very costly. So when you have a huge number of records, maybe in millions or billions, so it will take a lot of time. So your app become very slow. Okay, so it is not a very good user experience. Second option, what you can think is of the caching, right? Basically, you can cache some data into the your Redis cache or some cache, right, which is faster. But even then, you cannot cache everything, right? So for a few cases there might be cache hit, for a few cases it might be cache miss, right? So even then there will be a traversal toward the database. In that case also there might be a very slow response from the database, right? So even then we are using caching. It's not very efficient when we have records in billions, right? So another way to do this searching is that we can use the hash table. So in hash table, what we does, right? We basically try to hash the data, and basically we store the hash number, right, or key in the hash table. And whenever we want to retrieve it, we can retrieve it from the hash table, right? But even then in hash table, whenever there are collisions, right? So we have to use the linear approach. We use linked list, right? So and also you store the full data over there. So in that case, what is going to happen, that it will be very huge hash table, which is not possible to maintain for the billions of records, right? Because you whenever there's a collision in the record, you have to again traverse sequentially. So maybe for some small number of records, it might work efficiently, but when you reach in the billions of records, it is not possible to use hash table as well. Right, now let's understand the Bloom filters, how it works. So Bloom filters are basically an array of bits. So we can take an array, which is having the bits stored in that for every bucket, right? So here in this example, I have taken and array which is having the size of 10, right? So starting is from 0 until the 9. So we have 10 buckets of this array of bits, and every value in each bucket is initially 0, right? So, but whatever the length you can take is up to you, depends upon your application and your requirement. But there are some formula as well, right? From those formulas, we also find out the appropriate length of the array of bits, right? And second thing is that we also use some hash functions. So hash functions is, I think, you must be aware that it is utilized to basically get some output or some numbers, right? Whenever we pass some input. So, but whatever the value comes for a particular string, it will never change. So whenever you pass a particular string, it will always give the same output, right? So in Bloom filters, whatever the number of hash functions you want to use, you can utilize as per the requirements and your application design. And also there are some formulas like so you can basically whatever the length of your array and number of hash functions, right? It is a variable. It depends upon your use case, right? So here I have taken two hash functions, H1 and F2. So whatever the strings we want to basically search, right? So I mean, our example is that we want to search the strings which are not present in the database, right? So initially, so when we start with tech, right? So we have a first string called tech. So when we pass this string tag from these hash functions, so both hash functions give values like 3 and 7. So what we are going to do, we will set uh, 1 at position 3 and position 7, right? So whatever the value we are getting from hash functions, by passing these values, we will set those values as 1 into this position. So here you can see that we have set 1 at position 3 and position 7. Now, suppose you want to search the next string called with. So in with also, suppose we have got this values 4 and 9. Same case, we are going to put 1 and at the position of 4 and position of 9, right? So here you can see that we have flipped those zeros to the 1 for the position 4 and 9, right? So this is how you keep adding the bits, right, to your the positions whatever the you get from the hash functions. So let's see the third string which we have searched, called SAS. So SAS gave us the 1 and 8. So now we are going to set the 1 at position 1 and 8, right? So now so we can see that, okay, so here we can see that uh, it is setting as 1, right, for both positions. So now we have seen that we have such a few string like tag, with, and SAS, and we have got the respective hash numbers from hash functions, and we have changed 0 to 1 for those positions in the our array of bits, right, in Bloom filter. So now we are suppose we search few more strings. For example, now we search the techno. Okay. So again, same process. We pass techno into our hash functions and we get the values as 0 and 7. So now if you observe, right, from the Bloom filter array of bits, you can see that at 0 position, it is 0, right? And same position is 1. It means that this was never searched. Okay. So, I mean, so first three were basically, we were setting our Bloom filter, but now we are searching whether the particular string exists or not. So when we got the hash value for techno, it gave 0 and 7. But it means that there is no 1 at position 0 in the array. So it means that techno was never searched. So techno is a new string. I mean, search first time, right? Similarly, let's see a second example where we are searching the edu, right? So when we search edu, we get the hash function values as 4 and 3. So now you can see 4 and 3 both have the 1, right? So what it means that, it means that edu was searched before, but it's not the case, right? Till now we have just searched these four strings. Edu was never searched, but Bloom filter is saying that no, edu was searched before, right? So it is the case of the false positive, right? So in Bloom filter, right? So there might be a small number of percent cases or percentages where you might get false positive. It means that it will say, okay, even if the particular thing was not searched, it will say it was searched, right? So that is the one thing. So now, but it is fine, right? So, for example, if you have users of in tune of billions, right? So if there are like a few false positive happening in your system, that is fine, it's tolerable because you want efficient search, right? And every system, every framework, every logic has, every DS has some pros and cons, right? So there will might be a small percentage of error possible. But even if in the email use case, right, even if it says that it is present, why it is not, it's not harmful, right? User can choose a different username, right, for their particular use case. But the problem is that whether the false negative can exist or not, it means that it is saying that user exists, but it says it does not, right? So it is a very because if it happens, it might be a problem. So for that particular thing to happen, right? Uh, all whatever the hash number, right? All should be one, and for that case, but it will never happen because in the case of false, in the case of Bloom filter, right? Whenever whenever there is a at least one is zero, it means that particular string was never searched. So false negative is not possible, right? But for the okay, so I mean, yeah, so false negative is not possible because if even one bit, right, one bucket position is says zero, it means that that particular string was not searched. Okay, but in case of the false positive, you might need to do backend DB call to verify. So maybe in billions of record, 1% might need to verify whether it is a false positive or false negative, right? So that is the case. So that's how it is working. So I hope it is understood, right? So and let me revise again. So in Bloom filters, we take an array of bits and we take the hash functions, number of I mean length of the array and number of hash functions depend upon your use case, and there are some formulas by which you can find out. And then whatever the string you are searching, you pass them through the hash function and get the hash number output, and then you flip those position in the array of Bloom filter and mark them one. And whenever you search again, and if you see, okay, whatever the hash number you have got, if both positions have one, it means that that is the uh, previously search string, right? But if any of those is zero, it means that was never searched. So this is like in nutshell a very simple data structure that can be utilized for this use case. So now because of this, right? So we call the Bloom filters as a space efficient probabilistic data structure, right? So why? I mean, yeah. So let's understand each word and its meaning and definition. So it says like it is a space efficient. Why? So here, right? You are just storing bits, right? Not storing the all the strings or all data. So whatever the work you might do in GBs, you are doing some MBs, right? So because in Bloom filter, you are just putting the 0101 values, which is a very efficient or in the terms of storage, right? And why it is probabilistic? Because there might be some false positive, right? So, for example, in our case, right, we have seen that edu was never searched. but because of the other hash numbers, edu hash 4 and 3, and both were 1, right? So it gave a inference that edu was previously searched. So it gave a false positive. So it means that there is a there is some probability that there might be a wrong information sent, right? So for the false positive case, you have to do some provisioning in your application, in your logic, so that you are able to capture all the use cases, right? So this is the that's why Bloom filters are called the space efficient probabilistic data structures, right? So now, what use cases are good for Bloom filters, right? So we have seen the benefits, we have seen the drawbacks as well. So whatever use cases, for example, email use case, right? So in that case, if there are some, like a small number of false positives, it is okay, right? We can tolerate that. But if there should not be no false negative. So whenever you are designing any system or process, you should understand that which is case for you, right? So either if you are able to tolerate some false positive cases, that is fine, right? So now let's understand the some examples which exist for the Bloom filters where they are utilized in the real world. Like for example, Akamai, right? Akamai is a CDN provider. So they use, right? They use I mean they have this search, right? Various uh, URL, right? So they know that maybe there might be some one-hit wonders, right? For example, if you search one string, okay, suppose you search some very unique keyword, but you never come again, right? So they know, okay, whether do I have to cache it or not? Because if user is not going to search that particular URL or keyword next time, there's no point of caching it, right? So to verify whether that particular search is a one-time wonder or it is going to repeat in future as well. Akamai uses the Bloom filters to basically efficiently stop their caching system. Next is the Chrome. So Chrome browser, I mean, we know that, right? In the internet world, there might be very, various malicious hits happening, right, from various URLs. So Chrome uses the malicious, to track down the malicious URLs, it uses the Bloom filters because they might be in tune of millions, right? So it has either it can save all URLs database and search them through, or it can use a Bloom filter to identify whether it was hit by a previous URL or not, which is malicious, right? So Chrome also utilizes these Bloom filters in order to find out the URL is malicious and prevent it. Then, like we have web crawlers, right? So web crawlers, we know that they basically there are millions or billions of websites in the internet, right? So they basically search the websites for data. So at that time, for this case also, Bloom filter is utilized so that we know, okay, what are the URLs of websites we have visited, what are not visited, right? So this for this also Bloom filter is utilized. Then suppose for database, right? So database queries are happening. Suppose you want to search whether particular primary key exists or not. So what you can do, either you every time you go to database, do a search query, or maybe you can use a Bloom filter, right? So whatever the keys you are searching, you can set them as a 0101 in the Bloom filters, and you can basically find out easily without visiting the or without querying the database. So these are the few real world examples of the Bloom filters. So in nutshell, we can say that Bloom filter is really useful whenever we have a database or records in tune of billions, and we want efficient, less error prone search mechanism, and which is very good in terms of the efficiency. So Bloom filter is a very good example of such particular data structures. I hope this video is useful, and please like, comment, subscribe, and also kindly forward my videos to your techie friends to encourage them to basically subscribe. And if you want to basically want me to make some videos on other topics, please put in the comments box. I will try to create them as soon as possible. Thank you very much for watching. See you next time. Please leave comments or questions in the comment box. Please subscribe as well. Thank you very much.